Hello, International School, Braunschweig-Wolfsburg. Here we are with our next video lecture. We're going to be going over price elasticity of demand today. This is an important concept, and actually we're going to use this concept throughout the economics course. Really helps us, improve the depth of our understanding of supply and demand. So let's just go over some learning goals real quick. By the end of this lesson, you will be able to explain what does PED mean. You'll be able to define it and kind of explain what does it mean. You'll also know the formula for calculating PED, and you'll know how to calculate it, and also what does it mean, the values. So like when you look at the value that you get from calculating PED, you'll know how to interpret it. We'll also talk about why is it that the value of PED is always treated as positive. We'll go over that a little later. And we'll also look at these different terms that are associated with PED. So elastic, inelastic, unit elastic, perfectly elastic. We'll look at all of these terms. You'll learn how to define them and what does that mean. You also get numerical values to tell you what those mean too. So they can be explained with words and with numbers. We'll look at how the values of PED changes along the curve, and that we call all curves relatively inelastic. I know this all seems kind of new and unfamiliar now, but as we go over it, it'll become clearer. Finally, the last three topics are sort of more the real world application. Why do we need to know this? What is important about PED? How does it help businesses or governments make decisions on pricing or what to tax? Also, there's an impact on developing countries. So just know that there's this formula, or this concept rather, is important for a lot of different entities, helps us understand the world a lot better. All right, let's get into it. So when we think about different goods, we know that consumers will respond to price changes differently depending on the good. So if you imagine these four goods and the price all goes up by 10%, if you think about it, would people still buy the same amount, or would they buy a lot less, or would they buy like a proportionally smaller amount? Would they, price goes up by 10%, did they buy 10% less? So if you think about it, what we're really looking at is how sensitive are people to price changes? If the price goes up, do people buy a lot less, or not very much less? About the same. Pause the video and think about these four items. All right, well, now that you've probably noted down these four items, hopefully you got this correct, that with the insulin, it's a necessity. So if the price goes up, the quantity, the amount of people that, consumers that want to buy insulin won't change much. Whereas the car, on the other hand, just like mangoes, if the price goes up, there are lots of substitutes. So if the car gets more expensive, people might switch to another type of car or another type of fruit. With salt also, if the price of salt goes up, it's something that we have to have. We can't really live without salt, or we don't want to live without salt. We have to have flavor in our food. So, again, if the price goes up by 10%, the quantity will not fall that much. So all of this matters because it relates to the shape and the steepness of the demand curve, the slope. Let's go ahead and define the term real quick. Before we even really show you what this looks like, let's write down what this means. It's a measure of responsiveness of a change in quantity demanded due to a change in price. And again, what we're looking at is if the price goes up or down, are people going to be sensitive to that change in price? Will people buy a lot less? Will there be an elastic response, meaning like a large stretch in the amount that people want to buy? Or will it be something that's inelastic or not stretchy? Are people not sensitive to price and changes, or changes in price? So if the price goes up or down, do people basically buy the same amount? So that's what we're really getting to, is how sensitive are consumers to changes in price. And elastic would generally mean a big change, and inelastic not so much. Also, the IB, not always, but a lot of the time, when you have to define something, you could often you could use the term, which we just went over. You could also use the formula and often get the same amount of points. So just note the PED Depending on the question, you might be able to just give the formula, which is it's measured with percentage change in quantity demanded over percentage change in price. Just note that the delta here, this symbol, is just sort of the symbol for change. So often the IB will give you values, and all you have to do is plug those values into this equation, and you'll get a result, and you have to be able to interpret that result. Okay, let's take a look at what does this look like in the real world. So we've got two goods here. We've got two, well, we don't have the goods list, but we have two curves. We have two goods that are going up by the same amount in price, but we have hugely different drops in quantities. So when we were talking about the car or the mangoes, we see that if the price of a car goes up by 10%, it's probably going to have a curve more shaped like this, meaning that the increase in price is going to result in a huge drop in the number of cars sold. So we're going to have a big drop in quantity. And that means when we say that we have a big drop in quantity, we're saying there's a big stretch in the amount that people want to buy, or it's elastic. So just note that this is a relatively elastic curve, and people were very sensitive to a change in price, meaning they changed. Whereas like with the insulin or the salt, people kind of have to have that. So an increase in price may result in a small change in quantity, but not much. People were not price sensitive. It was price inelastic, meaning it didn't stretch. So we have a little change in quantity. And this is a relatively inelastic curve. Remember we said the formula was percentage change in QD over percentage change in price. Well, remember that the value down here, the change in quantity, goes on top. So over here you can see 20, drop in 20, increase in 10. So we have 20 over 10. And just note that, when we do that, we get 2. And any value greater than 1 is elastic. So again, if we calculate the number, and it's a number bigger than 1, then it is PED elastic. Whereas here you can see there was the same change in price, but the drop in quantity was much smaller. So when we do the equation, we do the 4% here, change in quantity, over the 10% here, we get 0.4. So if it's ever less than 1, it's inelastic. And just note that these values are important to know. If you get a test question where it asks you, is this an inelastic good or elastic good, you should be able to interpret that. Okay. We should be able to define the term inelastic too. As we said just a moment ago, it's a value less than 1 when you calculate PED with a formula, and basically you define it verbally as a change in price results in a proportionally smaller change in quantity demand. And that is, again, if the price goes up or down, there's going to be a smaller change in quantity than there will be a change in price. Whereas with elastic, it's always going to be greater than 1, and that a change in price results in a proportionally larger change in quantity demanded. So again, we've got these two concepts, and you just need to know how to interpret the number, or be able to look at the diagram and the slope and know if that's relatively inelastic or elastic. All right, one other note that we said at the beginning, that you would have to understand that we're always going to get a negative value when we calculate PED. I mean, if you think about it, if the price goes up, that'll be a positive change, but then the quantity will fall. So that'll be a negative change. So you'd get a negative value if the price went up here, or as if the price fell, you get a negative value, but a positive increase here. Just note that whatever negative value you get, if you get -2 or -0.2, you just write it as a positive value. That's fine. Okay. So knowing something about the goods can help you understand the shape of the curve. And we're going to go through some examples right now to help you understand, how do we know if a good is inelastic or elastic? What is the PED generally for most goods based on their characteristics? So first, in our acronym of how to remember this is plants, PLANTS, plants. And I think that's an easy way to remember it. Just note the first one is proportion of income. Y is the economic symbol for income. So if something is a small proportion of our income, we generally don't care much if the price goes up. So if a piece of gum or a staple goes from 3 cents to 6 cents, generally the drop in quantity isn't going to be much because people don't care. It's not a large proportion of their income. Whereas a car, or most luxury goods, which are expensive, tend to be a large proportion or chunk of our income. So a $3,000 increase in a car, 10%, is significant for a lot of middle-income families. So when the price goes up on a car, $3,000, there could be a huge drop in quantity because people will switch to other cars or similar comparable substitutes. So just note, the proportion of income has an impact generally on how inelastic or elastic the curve is. The next two, addictive and necessity, also kind of are very similar, and in that it generally tends to be that if something's addictive, you've got to have it. If, for example, if you were a smoker and you were addicted or something. Same with necessities, like we need them to live. We have to have them, whether that's water or shelter. It depends on the degree of necessity it is. I mean, some things are more needed than others, but again, generally addictive things and necessities tend to be more inelastic. If the price of water goes up, the quantity doesn't fall much because we've got to have it. Okay, next we have time, and just note that over time, things become more elastic as we find substitutes. Last but not least, substitutes, number, and closeness. If we have a lot of close substitutes, then if the price goes up just a little bit, there's going to be a huge drop in quantity. Or conversely, if there's a little drop in price, people will buy a whole bunch more because it's now cheaper than those other substitutes. So just note, if we have lots of substitutes, it's price elastic. Not so many substitutes, price goes up. We don't have anywhere else to go, or we basically have very other alternatives. So it would be inelastic. Okay, so just remember, remember this acronym PLANTS, it can help you understand if the curve is elastic or inelastic. Now, sometimes the IB will not give you the actual percentages. You might have to calculate that on your own. Fortunately, the percentage change formula is very easy. It's just new minus old over old. So, if the price goes up, let's say from 2 to 3, right? You would do 3 minus 2 over 2 for this part of the equation. And if you think about it, the price went up by 50% because 50% of 2 is 1. So again, 3 minus 2 is 1 over 2, right? So we would basically get a 50% increase in price if it went up by 50. Again, you would do the same thing with the quantity. Whatever value you get, you'd have a new quantity, probably a lower one because the price is going up, versus the quantity what it used to be. So just note that just new minus old over old, and then you have to move the decimal over 2 spots or just times it by 100, and that will give you the percentage change. All right. Now just note that sometimes, we were talking about how the curve, if it's really steep, it's inelastic, and if it's not very steep, it's kind of shallow, it's more elastic. What if it was just a straight line, perfectly vertical or horizontal? And what you can kind of see here is if it's perfectly horizontal, then it is perfectly elastic, meaning that all quantities are demanded at a single price. Whereas, here we have a perfectly inelastic demand. We only have one available quantity as the price escalates. So the quantity does not adjust to the same in price, or the change in price. Just note that, something that might kind of be like this, maybe you might have, for a real world example, something like a membership to Netflix or something, that as the price doesn't change regardless of the amount of people that want to buy it. It might be whether it's one consumer or 50 consumers, it's the same price. So at all quantities, it's the same price. Now, I don't know if that's the best example, but again, often we don't have this in the real world, these perfectly linear straight curves, but just sort of throwing that out there. Okay, so what does this mean mathematically? Well, if it's perfectly inelastic, basically the quantity demanded doesn't change at all. So, if we throw that into the equation, we're always going to have 0. If it's inelastic, it's more than 0, but less than 1. So a change in quantity is always going to be smaller than the change in price. If it changes by exactly the same proportion, right, if it goes up 10% in price and the quantity drops by 10%, then we call it unit elastic. That's also pretty rare, but can happen. Finally, elastic, if it's going to be bigger than 1 but less than infinity, and basically, the change in quantity is going to be bigger than the change in price. And last but not least, perfectly elastic, which is infinite. And basically, people will buy everything they can at a given price. And that's the only guidance I have. Okay. So just note that when we look at a curve, you might say, oh, that looks more elastic, or that looks more inelastic. But actually, you should remember that the values change as we move along the curve. I mean, if you think about it, the price goes from 1 to 2. That's a 100% increase. So the denominator, the number on the bottom, it's going to be a big change. Whereas if we go from 4 to 5, that's a 25% change in the denominator. So as we move along this curve, as we go up, these values, the percentage change, will get smaller. But as you go down here, that then the percentage change will actually get bigger, right? So just note the changes. And what you could kind of realize is that when you look at a demand curve, that we've got kind of 3 sections. We've got this section, and a kind of a little dot right in the middle. Just note that if we were to look at the example from a moment ago, as we move along the curve, here we get 0 because we're starting from 0. Then we would get 1/4, 2/3, 1/5, and then 4. So as we move along the curve, those values change. This will be important for something later, but just note that the values do change as we calculate the PED as we move along the curve. That's why we say the curve is relatively elastic or inelastic. Okay, kind of a TOK thing too. I mean, if you look at the spacing of this curve, how that impacts our perception. I mean, with the 2 values here are 5 and 5, but we've spaced out the quantities so much that it makes the curve look elastic, right? It's not very steep, but if they were proportional, it would look different. So, I mean, again, how we create graphs and diagrams does impact our perception of numbers. My TOK question of the day is, where does this also happen in the real world, where stats get manipulated, or math at least can be manipulated, so it gives us the wrong impression? Okay. Anyway, let's add a little bit of depth. We haven't watched this yet. I'm sick this week, so I can't really show you this, but we were going to talk a little bit about Luxottica, which is a manufacturer of eyeglasses. And they dominate the market. I mean, they almost basically have a monopoly in some countries. So, when we think about PED, and if you think about the type of goods that there are in the market, if you were a manufacturer of eyeglasses and you were the only one, if you were a monopoly, would you want to raise your price or lower it? Why? Well, if you think about it, if you're at Luxottica and you're selling eyeglasses 100 a day for 400, you raise your price by 100. We only have a small drop in quantity. Was it a good decision for Luxottica to raise their price? Absolutely. For them, right? Because glasses are a necessity. So if we can't live without them, an increase in price will lead to a small drop in quantity demanded. So that tells firms that, depending on the type of good they have, If they're in the inelastic portion of the curve, they should raise their price. Conversely, when you think about t-shirts, right? If you've noticed, like, t-shirts are really cheap. You can go to TK Maxx or maybe C&A or different clothing stores like what is it called? There's a Kick or something here in Germany. These, you can get shirts very, very cheap. And over time, if you analyze the price of shirts, prices are lower adjusted for inflation. So if you think about that, have firms been doing that for a reason, right? With for example, chocolate or shirts. Oh, I know this says chocolate. I couldn't change the infographic here, but if the price of a shirt drops a little bit, there's so many different substitutes that, firms know this. If they drop the price of a shirt just a little bit, hopefully they're going to sell a whole bunch more. So when we look at the revenue, initially it was P1Q1, but we dropped the price. Now we sell P2Q2. So we lose this little purple box, but we gain this big blue box. So, if you're a firm, and if you've got a good that's PED elastic, or you're in the elastic portion of the curve, you want to lower your price. But let me just go back to another point. This diagram here. Just note that it also depends on the curve and where you are in it. So if you're in the inelastic portion, you would want to raise your price, because you know that if you raise your price from here, going up in price will lead to a smaller proportion change in quantity demand. So the company will make more money. So again, it depends on where the company is in the curve. If you're in the elastic portion of the curve, you know that if you drop your price just a little bit, you'll sell a bunch more. So most businesses want to hit the sweet spot, which is unit elastic. That's the magic number one, that we want to hit. So firms will always have a goal of selling at the unit elastic price. And if they also know that they're in the inelastic portion, they want to raise, not lower. And if they're in the elastic portion, they want to lower, not raise. So just note that knowing your product and knowing your price setting power and where you are in the curve can help firms make more revenue based on that knowledge. Okay. So we also said that we'd briefly talk about goods that have inelastic demand versus elastic demand. And generally, when we think about commodities like raw materials like timber or wheat, these tend to be inelastic, meaning that, if the price of wheat goes up, the quantity doesn't drop much, right? It's inelastic demand because it's a necessity. So wheat tends to be inelastic, whereas you look at something like a toaster or a microwave or a television, it tends to be more elastic. It's more of a luxury. There's more substitutes. So a drop in price on a manufactured good usually leads to a big increase in quantity. This is important for a couple of reasons. A lot of developing countries, LECDs, which maybe tend to have lower GDP per capita, they tend to sell a lot of raw materials and a lot of commodities. So what that means is that if there's ever a change in price for the goods in those countries, there's going to be a huge change in price relative to the change in quantity, which kind of makes the income from exports in those countries unpredictable. So just note that it tends to be that inelastic goods, raw materials like wheat, timber, rice, that sort of thing, are inelastic demand, and that impacts the revenue from exports for some countries. Whereas, you look at like developed countries like Germany selling cars, or maybe the Japanese selling televisions and whatnot. Those tend to be more elastic demand. And the income, because the price won't change as much as the quantity, tends to be a little bit more stable and predictable. We'll talk a lot more about this in classes. It's just kind of a little overview now, but just note that commodities are inelastic and manufactured goods tend to be elastic. All right, so we're going to do some practice. We'll talk a little bit more about government revenue and some other things, but I'm going to give you a practice sheet to do. please do that and upload it to ManageBack, and then we'll go over the answers, or I'll publish the answers for you. All right, have a great week. Take care. Schulte out.